Hey guys, I'm finally getting to do the extra practice that I was hoping you could do by turning in today in class, although it looks like most of you really struggled with it. So I thought I would be really super nice and come along and do a couple of these with you. And remember, anytime you have a tangent that runs into a radius, we have what kind of an angle? It is a right angle. That is really important for so many reasons. They also are telling you up here that if it appears to be tangent, remember it is. So that's one thing that they're testing here. And I know that's a radius, so I know this is a right triangle. Now this morning I noticed that one of my students realized that this was a kite. So I just want to remind you of a couple things. Tangents that go to the same circle from the same exterior point are always congruent. So this line is congruent to that line. And we also know that a radius is always congruent to another radius. So this is a kite. We know that all of the angles in a kite sum to some number, and we're going to use this formula to find out what the sum is of all of those angles. And the n is how many sides? Well, this has 1, 2, 3, 4 sides. So 4 minus 2 times 180 equals 360 degrees. So I know that all those angles in that triangle, this quadrilateral, has to add up to 360 degrees. So let's do that. Let's say this one is 90. This one is 115. This one is 90. And then this one is x. So when we sum all of those up, that means I add them. So let's do that. 90 plus 115 plus 90 equals 295. And I know most of you can solve that. I'm not going to go ahead and give you the answer. I want you to see if you can't figure that one out. Right here, once again, we have a radius and a tangent. So what kind of an angle is this? A right angle. I spy a right triangle. So the hypotenuse is x, 6 squared plus 8 squared. That's your C. Okay? I think everybody can do that. Here's a tangent again. That's 4. That means this one has to be 4. So what is the length from here to here? Well, 10 minus 4, or 6. I know that the tangents, once again, are going to be congruent, so that means x is 6. Number 4, 5, and 6, they're giving you a question. They want to say, is it a tangent line here? And so I want to know, is this a right triangle? That's the question. So remember when we used to say a squared plus b squared is what to c squared? If it equals, I know it's a right triangle. If a squared plus b squared is larger, it means my c squared is small, so I have an acute triangle. If a squared plus b squared is smaller than c squared, it means I have a large hypotenuse, which means I have an obtuse. So let's just plug in my smallest side, my medium side, and my largest side. So, and I would just stick it all in the calculator just like this. I would say 15 squared plus 20 squared gives me 625. And what is that to 25 squared? 625. So if they are equal, then yes, it is tangent because we have a right angle. That's what you're going to do on 5 and 6 as well. Now in 7, I spy a right triangle. There it is. 8, 3, x. Well, it's not x, because x is this whole thing. That was silly of me. So this is the whole x. This is only part of x. So let's give it another name. Let's call him y. And that way you know when you get y, you have to double it to find x. I'm not going to do it for you. Don't worry about 10 and 11. Oh, I did this too. This is kind of helpful. This is a diameter. It's 12. What is that? It's a radius. How long is it? 6. What is this? A radius. Oh, it's 6 too. Can't I draw a radius right here? And it would be 6. And now I have a right triangle. 6, 3, x. Hopefully you can see that. I spy a right triangle. Okay, down here, let's look at 12. 12, we're going to be looking at lots of different things. Right here is an inscribed angle. And when we go out from this inscribed angle, I know that because the vertex is on the circle. This is 77. What is it when it comes out? What's 77 times 2? So this is 154 because it's 77 times 2. So I know this arc right here is 154 degrees. They want me to tell them what this little angle is right here. Isn't that just finishing out the 180? I could do it that way, couldn't I? I'd know that this is, the whole thing is 180. 180 minus 154 is 26. So I know that angle right there, if it was a central angle, would be 26. Bye, Dante. Have fun. But it's not a central angle. But I know that this arc is 26. Still not real happy with that. Alright, well that's easy enough to fix. We know that arc's 26. Can we figure out this arc over here? I know this whole thing is 180. 180 minus 54 is 126. So I know this arc is 126. So this vertex is inside the circle. So I know I'm going to add my two arcs. So angle B equals 126 plus 26 divided by 2. So I know that angle right there is 76. Okay? Hopefully that helps you. I think I did it different in class. I couldn't remember how I did it. But remember, you can do problems lots of different ways and still come out with the same answer. So just because you did it different than I did doesn't mean you did it wrong. If you got the same answer, then you probably did it right. And third period, I think I told you that opposite angles in an inscribed quadrilateral are supplementary, but then we went ahead and did the problem wrong. I need to know that 75 plus A equals 180 degrees. So I've got to subtract 75 from 180, and I get 105. So angle A is 105, and I think in class we said that that angle was congruent, and that was wrong. I mean, I know we said it was supplementary, but I think we did congruent, and that was just a little crazy. See if you can't figure out B there. Looking back here, we have lots of inscribed angles. Here's one. For some reason, this is the one that always jumps out at me first. I have that one. This angle's 36. When I come out, I double because it gets bigger. So 36 times 2, this angle is 72 degrees. This arc right here is 110. So when I go into that inscribed angle A, I have to take 110 and divide it in half, and I know that that angle right there is 55 degrees. So we have 110, we have 72. What's left over here for this side? Well, we would take 360 degrees, and we would subtract 72 and subtract 110. And what do we get when we do that? And I know that's 178. So right there's angle C, arc C. This is an inscribed angle to that arc. The vertex is on the circle. So in order to go in, we divide, we make it smaller. So 178 divided by 2 is 89. So then we know that D is 89 degrees. Hopefully you're recognizing that inscribed angles are on the circle. Central angles, which are congruent, are on the center. And then we have our little ways where we've got to add two arcs. And that's when it's not on the circle or on the center. Okay? Let's do another one here. In this one, my vertex is outside the circle, but they give me this arc. Remember, we said that it's got to be inside the mouth. We only care about those arcs that are inside the mouth. I know this one is 72. I know this one is 95. Can anybody tell me what this arc would be? Well, the whole thing I just colored is 360 degrees. So 360 minus 95 minus 72 leaves me with that purple arc. So 360 minus 95 minus 72 is 193. So now I know my major arc. We know that this angle Y equals the biggest arc, 193, minus the smaller arc, which is 72, over 2. Now, why did I choose 72? Remember, it's inside the arms. Let's put that in the calculator. I like to use parentheses. I think it's cleaner. Plus, if you include the numerator in parentheses, you're almost always guaranteed to get the problem right. When you don't, you kind of can make lots of little mistakes. So angle Y is 60.5 degrees. Same kind of problem here, except that arc is a tangent, and I know this much of it's 110. What's the whole circle? Notice that my vertex here is in the circle. This is that type of problem I was talking about earlier when the vertex is in. It's not on the center or on the side. It's inside. And I'm going to find angle X first. It intercepts this and this. So we're going to take 140 and we're going to subtract 85 and then divide by 2. So the answer is 27.5. Now, I don't know if any of you noticed, I just did the subtraction, found my answer 55, and then was divided in half. So if you don't like using parentheses, you can always just do it that way as well. So I know this angle right here is 27.5. Do you see that these two together are a linear pair? That means that angle Y plus 27.5 has to equal 180 degrees. So 180 minus 27.5 is 152.5 degrees. Okay? Here are these. There's my vertex. This is one line. This is another. The key here is we're finding lengths now. We're not finding arcs. So we have 10 times x equals 7 times 8. 10x equals 56. That's one of those I can never remember. X is equal to 5.6. Okay? When the vertex is inside, we multiply the pieces of the same line, and they equal each other. Over here, outside part times the whole thing equals the outside part times the whole thing. Let's do that again. Outside part times the whole thing. That's x times x, or x squared, equals the outside part times the whole thing, which is 6 plus 12. And some of you can add that very quickly, and you'll know it's 6 times 18. And I'm not going to go from there. You can solve x at that point. These problems are all the same. Notice on this one, vertex is inside. So to find that x, you're multiplying the parts, okay? Just inside the circle. That's that problem right there. And then